in the past.
Even then, because in fact, the European countries, Russia, they have been our example for a long time in terms of superior instruction. And you can see it among Asian communities. Even here in New York City, there's a difference in their approach.
What's their approach?
One of the things is the children are asked to practice their skills. There's some explicit instruction involved. The children have in their bones the basics of arithmetic, so that if you go to Macy's and you want to know what 20% off is, you know that's 1/5. I mean, there are different ways to calculate, and any of those
ways to calculate it.
And I would say that if you look at not only the trends in national assessments, but in the reports we're getting from the faculty at the undergraduate level in our colleges and universities, both locally and nationally, what we're seeing is children are coming in, well, they're not children, young adults are coming in knowing less and less than they did before. So, of course, there's the example of people who did not thrive in their particular math instruction in this country over many, many decades. But it's also the fact that there are certain very distinct differences in the programs and the approaches used today from mid-'80s that have put us even further behind.
I want to play devil's advocate, because you mentioned the earlier example of asking students to work in groups to find the solution to a multiplication problem, and the different ways they might find that versus maybe the way I would do it, just the carrying and the crossing out. But what's so terrible about children having a conceptual understanding? I mean, you know, when I multiply and add, it's rote. I do get the right answer most of the time, but it's rote. And I don't really think I give much thought to the concepts that are underlying the things that I do, the algorithms that I use to get to that answer. So what is so wrong about asking students to have an understanding of the concepts?
Well, now you mentioned a couple of things. One was group work, which is absolutely fine.
Okay.
Group work is fine, and children sometimes learn more from their peers than they do from a teacher. There's nothing wrong with group work.
Okay.
And of course we want conceptual understanding. There is no one who doesn't want conceptual understanding. However, there also is the fact that in basic arithmetic, the purpose of these procedures is that so that you get to the point where you don't have to think about it anymore, so that you can go on to levels of mathematics where it becomes a lot more interesting and it becomes more creative and wonderful in the applications. If children are still struggling with basic math facts and ways to solve problems in an alternative method that everyday math espouses, such as lattice multiplication.
What is lattice multiplication?
Well,
sorry to stop you, but
yes,
I never even heard of it.
You can find it on our website, or you can find it on the Everyday Math website, or in lots of books. It's boxes, like a lattice, a fence lattice, I guess, and it's a structuring of the long division algorithm in a different way that comes out with a proper solution, but it doesn't teach place value, and it also is not useful beyond the teaching of it at the particular level. And what we have to be able to do, we have to be able to bring the children to a place when they enter middle school where they are prepared with the math they need to begin the next level. Math is hierarchical, it layers. You can't jump around as everyday math does. You can't ask for partial mastery. You can't emphasize alternative procedures to the exclusion of traditional methods and then advance the children into algebra. It doesn't work. The children are not prepared.
Would the drill and kill accusation apply to what I mean, in other words, when people look at reading and they looked at what used to be an over-reliance on phonics, that's why we moved away from that, and now we're trying to find some middle ground. Would it be a concern to you that this emphasis on math algorithm might result in the drill and kill approach, and why not? So
well, first of all, there's no one advocating for a program that is nothing but drill.
Okay.
That's not even close. What we're concerned about is the fact that the arithmetic has been taken out of the programs, and also the fact is children do need to practice anything. If you look at the way someone learns tennis, or the way someone learns to a musical instrument, or an actress learns to prepare for a performance, there's an aspect of memorization that's important. There are aspects of that skill and that art that requires mindless activities. In other words, you want to bring children to the point where they don't have to think what 4 times 8 is. They don't need to do this. They don't need to draw pictures. They know it, and then they can move on, and they can be free to advance into more interesting mathematics.
Okay.
So that it's just a matter of balance. There are 3 components in math instruction.
And
there's skills, there's concept development, and there's problem solving. All three of those must be there, and they must be balanced. And that is what is egregiously missing in a program such as Everyday Math and in a program such as Turk Investigations. It is absolutely imbalanced in the extreme.
Now, there is a program that I've been reading about called Singapore Math, and that supposedly has been very successful. What do you know about Singapore Math, and are you an advocate of it?
Well, Singapore Math is a very popular program in many areas.
Are New York City schools, any New York City
New York
schools
City
using it?
has very limited use of Singapore. It is used in several of the highest performing elementary schools. It was not chosen by Chancellor Klein. One thing about Singapore primary math, there are several editions of Singapore, and we want to make sure that we're talking about the Singapore Math program that reflects the instruction in Singapore. Singapore is top in the world. Those kids have their arithmetic and their mathematics down cold, and they are the highest achieving at points in time of any other nation on the TIMSS, which is our international test. Now, the program Singapore Primary Math is exactly the program that the students were using in Singapore when they were achieving these incredibly high top in the world scores. What makes Singapore Math so wonderful is that it really does what some of our so-called reform math programs such as Everyday Math promise to do but don't deliver on. The content is there, the conceptual development is there, the problem solving is very sophisticated. And so you will see, for example, in 4th grade Singapore, an amazing accomplishments on the part of the students because they've been prepared in the earlier grades, they know their arithmetic, and the complexity of the problems that they are solving is really phenomenal. It requires multiple steps to solving a problem where most of our children are doing just one step, very simple problems, if at all.
And what do you see then as the role of teacher education in preparing our students for success in math?
All of this hinges on what has been going on in our schools of education and what must change in our schools of education. Our schools of education train our teachers, and they also are involved in the research and development projects that involve our children in many areas of education. And it is rather remarkable that in most schools of education, teachers that are going to work with children in kindergarten through 5th grade or 6th grade, elementary school teachers, to receive their degree, do not have to take but maybe one math course. They're not required to take the math that they really do need. And this is extremely problematic. That has to change. The teachers need to learn math to the degree that they'll be prepared to teach.
In the minute that we have left, I want to ask you, what can parents do to improve their children's math education?
Well, first of all, they need to know what their children are being taught. They need to become familiar with the program. They need to look at what's coming home in the backpacks. They need to follow up with what's returned to the school. They need to go on the internet and find out information about the programs that their children have in the schools. And what we're finding in oftentimes, many cases, is that parents have to take the education in the math into their own hands. Unfortunately, this is what a parent has to do first and foremost before anything else, is take control of their children's math education if their children are attending a school that uses Everyday Mathematics or Turk Investigations.
What can a parent do with a young child? I mean, are there things we can do for our preschoolers to help get them ready for math, to understand math a little better?
Yes, I mean, there are all sorts of things you can do, and we see it in books at Barnes & Nobles and everywhere. You integrate mathematics in all of its forms in a child's experience from the very beginning when they're still infants, and in, playing and counting
sorting
and separating, sorting and patterns, and, the children, and cooking with children is another way. And, there are many wonderful ways to bring mathematics into a child's experience, and they think it's fun. Contrary to popular belief, children really have a great time in learning things, in knowing things well. They're proud of themselves when they know their multiplication tables and when they're doing real math. It makes them feel good and it makes them feel powerful, and that is what we're denying our children by not teaching them arithmetic in these programs.
We're going to give Jim Carney's guest the final word. We'll go back to the NYU Quran Institute and hear what's at stake in math education.
What's at stake?
What's at stake is the future prospects of the younger generation and of the society as a whole. Can't get any bigger than that, I would say. That's to say it matters both at the level of the individual family, parent and child, and it matters also for the society as a whole. It's a great concern that we're not doing as well as we should be doing competitively, that our curricula are not adequately rigorous, that the kids are not getting all the instruction they should get, that they're not being stimulated by concrete mathematics, substantive mathematics as much as they should be, and that many of our kids are at a disadvantage, which will affect them in ways that are painful. And we don't want that to happen. We want them to thrive.
Oh, man. There are a lot of countries whose kids take very seriously proficiency in math skills. This is an important factor in modern economies. They're going to eat our lunch. They're already eating our lunch. You know, the Indian schools India has a long mathematical tradition, and some of the strongest mathematicians in the world are Indian, and there are some Americans and Russians, and math talent is uniformly distributed. But if you don't respect it, and you don't nurture it, and you don't give kids, do your best to give every kid the opportunity to do real math as opposed to fake math, you're going to fall behind.
Welcome back to this edition of Ed Bites.
Many schools are experimenting with replacing textbooks with e-books. To judge the effects of the potential switch, California State University conducted a digital textbook rental program to gauge how well the e-books worked for students. They report 3 major findings. More students purchased e-books than physical textbooks, the digital material was easy to use, and students mentioned the benefit of the lighter weight e-books. E-books did not, in the end, provide most students with a satisfactory experience. Only a third liked the experience, with the remaining either neutral or dissatisfied.
And now for some economic news for our CUNY colleagues. If you didn't already know it, a new study by the American Association of University Professors reports that university faculty salaries are only slightly better than last year's and continue to not keep up with inflation. Overall, professors in private colleges and universities outpace their colleagues working in public higher education. In other words, professors at NYU and Columbia earn more than faculty at CUNY. In addition, nationally there is an ever-growing reliance on part-time faculty and non-tenure track positions. Yet, during this recessionary period, AAUP reports that the average salary increase for college presidents was twice the average faculty salary increase at public institutions and nearly 3 times the faculty salary increase at private institutions.
Treating children as gifted may actually make them so. Education Week reports on a North Carolina program called Project Bright Idea that demonstrates that at-risk students who are taught as if they are gifted and talented performed better academically. Teachers in this study received intensive professional development aimed at instruction for gifted children. The implications are clear. Dumbed down instruction for children perceived as academically troubled is the wrong way to go. Instead, all children should receive a challenging curriculum.
Do kindergarten kids need iPads? And Maine's school system thinks so, and they unanimously voted to require the iPad 2 for all its kindergartners next year. The district estimates this will cost about $200,000, including a special deal with Apple. So, what do you think? Is it ever too early to give our children technology? Does the iPad belong in kindergarten? What should the work of kindergarten be? Let us know what you think. Write to us at cunyedcast@gmail.com.
I hope they have insurance on those iPads and that they're peanut butter and jelly proof.
Absolutely. And that's it for this edition of Edcast.
Thanks for watching. Until next time, class dismissed.